Hi everyone. In this video, I want to show you how to evaluate the resilience of your applications with LitmusChaos, Prometheus, and Keptn. For this, I'm following a tutorial from tutorials.keptn.sh, and I will also link this tutorial in the video description, so make sure to check it out. So for this tutorial, all you need to do is to bring your own Kubernetes cluster to get started. I brought my cluster from GKE. It has enough nodes and vCPUs, so I came with a cluster with 8 vCPUs and around 30 gig of memory, and so I can install everything that is needed in this tutorial. First part is that we are going to install istio. We will need it later on for traffic routing. I've already downloaded the istio CLI here, so I can already go ahead and install this on my cluster. So here in my terminal, I'm already connected to my cluster, and I just execute the istio installer here, and I just let it finish the installation for a second. In the next part, we will download the Keptn CLI, and we will then also install Keptn on our Kubernetes cluster. There are different ways to download the Keptn CLI. I have chosen the first way just by using a curl to download the Keptn, the most recent Keptn version onto my local machine. And then I'm going to install Keptn from my local machine in the Kubernetes cluster that I'm connected to. So let's just look back if istio is already installed. Not yet. We're still waiting for it to be installed, but it should be finished just in a second. So I can already go ahead and copy this command, which will install Keptn, or actually which will download the Keptn CLI on my local machine. And then we are going to install Keptn into the cluster. So let's download the Keptn CLI, which should just take a second. And in the next part, we're going to install Keptn into our Kubernetes cluster. We will use the cluster IP endpoint service type for Keptn. We won't expose it via node port because we will do this part with istio, the exposure of the Keptn API and the services that Keptn manages we will do with istio. So istio will be our ingress in this example. And the use case we are having for this installation is the continuous delivery use case. I will just talk about this in a second, but first let me go ahead and install Keptn into the cluster. Just move this a little bit. We're going to do this by just copying this command here into our terminal. And it will ask us if we want to actually install it on the cluster. Mine is called the Litmus tutorial. I will go ahead, yes, and we'll install it into the cluster. So this will take about 3 minutes to install. Let's take a look what is actually installed here. So we are choosing here the use case continuous delivery. That means that we are not only installing the control plane of Keptn, which you can use for example, the quality gates use case of Keptn, but we're also installing some services from the execution plane, like the Helm service or the JMeter service, that are responsible, the first for deploying our application, and the second one, the JMeter service, to be able to send some load tests, some JMeter tests against our microservices that we actually manage with Keptn. You can also just install Keptn control plane and later on then install the Keptn execution plane services by yourself, or you can just go ahead and use this use case flag in the Keptn installation procedure. So in my case, I want to install Keptn, including the execution plane services like the Helm service and the JMeter service, as we're going to need this in this tutorial. As said, it will take a couple of minutes to be finished. Let us take a look here, and it's already finished. Keptn has been successfully set up on your cluster. So that's perfect. Let's move on and now configure istio to be the ingress for our Keptn installation. For this, we have provided a sample script, and we just download this, make it executable, and then execute it. So in the first step, I just downloaded the script and I will just add the executable flag to it. And now let us just execute the script. So it will basically set up an ingress for Keptn and a gateway, and it will also restart the Helm service pod as it should pick up the new configuration that we have just changed here with the script. In the tutorial itself, there is actually also the description, what is really going on, but we want to focus then on the use case later on. I just want to walk you through this to see how long it takes to actually walk through this tutorial. So let us now connect our Keptn CLI to the Keptn installation that we just did on our Kubernetes cluster. For this, I'm copying these two variables here, the Keptn endpoint and the Keptn API token. They will be fetched by this kubectl commands, so no need for me to know the Keptn endpoint and the API token myself. We have provided here some utility functions. And in the next part, I can actually authenticate now the Keptn CLI against the Keptn cluster. And here we go. I am now successfully connected against my cluster. Just open this. And here we are. I have access to the Swagger UI. That is our API documentation. And I see it's the correct version of Keptn that has just been installed. That's great. So let's move on in the tutorial. We've also provided a couple of demo resources for you to use. And let us just download them from GitHub. And we have everything locally available on our machine. And I think I already did this earlier. So let me just remove the folder where I downloaded it and download it again. And here we go. And we just jump into the right folder here in test data. We have all the data that is needed for this tutorial. I just switched into this folder. Now, let us install Litmus in our Kubernetes cluster. LitmusChaos is actually the chaos engineering framework that we are going to use for this tutorial. And we can execute chaos experiments with LitmusChaos, following a very cloud-native approach by defining the chaos experiments as YAML files. So I've installed Litmus, and in the next part, I'm already creating a namespace. This is actually the namespace where later on our application will live. And I will just create some custom resources and RBAC rules in this namespace that we will be using later on to be able to actually delete pods via the chaos experiments in this. Okay, next step is to set up Prometheus, and it's actually the installation of Prometheus inside the Keptn namespace. So we are adding the Prometheus services, one for configuring Prometheus and the other one for reading data from Prometheus to our Keptn namespace. So the first one is our Prometheus service, which will be responsible for configuring and creating a Prometheus instance. And the other one is our Prometheus SLI integration, which is responsible for retrieving data from Prometheus. So I'm installing both into the Kubernetes cluster. The next step is we want to actually install a Litmus integration for Keptn. So this integration is responsible to listen for events from Keptn and then to trigger LitmusChaos experiments via the LitmusChaos operator that is already running now in our cluster. So this service YAML has been downloaded from the repository from earlier. In step number 8, we downloaded the demo resources, and we are just going to apply the service, the Litmus service that is, its definition is stored in this folder. So let us run this. And since this is now created, let us take a look on all the pods that are now already running in our Keptn installation. So The Keptn installation lives in the Keptn namespace, and we can see a couple of pods are running, including the Litmus service that is already running in our installation, in our Keptn installation. Perfect. Now let's go ahead and create a project. So we want to create a project basing on this shipyard definition. And the shipyard definition has one stage, it's the chaos stage, and it has one delivery sequence where we actually want to do first a deployment, a test, and then an evaluation. So let's, sorry, wrong copy. Let us first copy this line, and now let us create a project. Here we go, project successfully created. I have not yet defined a Git upstream for this repository. So right now, everything is stored in the Git repository managed by Keptn locally inside this Kubernetes cluster, which is fine for the moment. Let us now onboard our service. We call it the Hello service, and we have all the charts, the Helm charts already defined in our test data repository. So we're just going to create this service here in our demo Kubernetes cluster. And in the next step, we are now going to add some JMeter tests. First, a load test and some configuration, how we want to execute this load test. So I'm copying both lines and adding this also to the Keptn installation. Here we go. Next step is to configure the quality gates. What we want to do here is to add some SLI YAML, which is the information how to retrieve the data from Prometheus, and also the SLO.YAML, which is our actual quality gate. And we will see this just in a second, how this quality gate will look like. Let me first add both files to our project. And now let's take a look on the SLO file, hello service SLO.YAML. So what we can see here is we have defined two SLOs. First, the probe success percentage and also a probe duration in milliseconds. And for the first one, we define it will only pass if the criteria is higher than 95%. And that means that success percentage has to be higher than 95% for it to pass, or we would get a warning if the success criteria is higher than 90. And I just see that there is actually a little bit of a typo here in the comments, but what's really important is the criteria here in the warning and also in the pass, in the pass property here of our SLIs. And for the probe duration, that means if the probe is faster than 200 milliseconds, we will get full score for this criteria. And if not, we will get 0 points for this quality evaluation. Okay. So now let's add our chaos experiment to the Git repository that is managed by Keptn. Also here, this experiment is already defined for you to use. We just copy this and execute it. So we are adding from our local instance, we are adding the experiment.yaml onto our Kubernetes cluster. Actually, the Git repository in the Kubernetes cluster that is managed by Keptn. One final step for the setup, let's say, we want to configure Prometheus for our Litmus project and our Hello service application. And we also want to add the Prometheus black box exporter. We will do this because our application is actually going to be removed. The pod in which our application is running will be removed by the case experiment, and we need some way from the outside to check the availability of the service, because the service won't be available for a couple of seconds. And we're going to do this with the black box exporter. So with this, first we're going to do the Keptn configure monitoring Prometheus that will set up Prometheus and also alerting rules for Prometheus, which we won't use in this example, but usually this is what Keptn configure monitoring Prometheus is doing. And in the next part, we're going to install our black box exporter. Here we go. Finally, we need to restart the Prometheus pod in order to pick up this configuration. So this is done really fast, perfect. Now we can run our application for the first time, or our experiment for the first time. Let's do this with Keptn trigger delivery. This will not only trigger the delivery, but actually the delivery sequence. And we have defined a couple of tasks in this delivery sequence, like the deployment, the test, and the evaluation. Let's go ahead and trigger the delivery sequence. Now, we also want to follow along what's really happening. And for this, we are going to take a look in the Keptn's bridge. We can retrieve the URL of the Keptn's bridge with this command. It will give us the URL, and we also need a password, the username and the password. And this is done with Keptn configure bridge -- output. And this will give us the password for this. Keptn and the password. And here we go. We have our Keptn's bridge. We have our Litmus project that we've just created. And in the Litmus project, we have one stage, the chaos stage. And we can see the delivery is already running. So let us take a look at the delivery sequence. Here we go. In the delivery sequence, we can see the deployment is already finished. We can actually take a look on the deployment. Oh, the hello from the Potato Head application is already a prompt here. And we can see currently the Litmus service is running and the JMeter service is running. So the Litmus service is sending the instructions to LitmusChaos to start the chaos experiment. And the chaos experiment that we have added to our Keptn managed Git repository are the pod delete experiment. So LitmusChaos will go ahead and delete the application pod, actually the pod that we just created during the deployment stage, deployment phase. And while this is going on, JMeter will fire some load against our application. So with this, we can make sure that our application that we are testing is actually under some load. That is important because we don't want to evaluate the resilience of our application if there's nothing going on, if it's not under load. So we would measure then the impact of chaos in an idle situation, and we want to evaluate the impact of chaos in a real-world scenario, in a real-world setting where there's actually some traffic going on fired against our application. So this is what we are simulating here. And we're not doing this in a production stage. We are doing this in any stage prior to production. In our case, we just called it a chaos stage. So while I was talking, both the JMeter service as well as the Litmus service finished their job. And we can already see the evaluation scored 0 points. We can even take a look why it scored 0 points. We can take a look here, clicking on this little icon here, and we see the probe success percentage was only 65%. So only 65% of the time of the evaluation period. The evaluation period is actually around 2 minutes. This was the time our tests were running, and we could not satisfy our pass or warning criteria. And we could also not satisfy the probe duration in milliseconds. We would expect it to be faster than 200 milliseconds to respond to the probe, but it took more or less twice the time. So what does it mean? It could not respond to all the requests that were sent from the Prometheus black box exporter, and it would not be able also to respond to all the requests that are sent by real users. So what we now want to do is we want to First, let's say we want to increase the replica set of this application. Instead of running only one instance of this application, let's run 3 applications, 3 instances of this application. That means if our case experiment is going to delete one of those instances, 2 instances should still be available and should be able to serve the traffic that is fired from JMeter against our application. So let's do this. Let's follow the tutorial. Actually, everything that we just saw is also has also been shown here in the run experiment step, where we can see that the experiment failed. So let's now increase the resilience of this application. And let's take a look on the deployment event that we now want to send to our Keptn installation. So it's in the hello service, and it's called deploy event. So the important part that I want to focus on here is the replica count. So just with sending these instructions here, it's a cloud event holding all the information that is needed for Keptn to trigger a new delivery sequence. And the important part that we want to change here is the replica count. We are using the same image as before. We are just changing the replica count to 3. That means we will now run 3 instances of our application. And before we go into do this, let me just open another tab here so we can watch the actual application, how it will be scaled up and how LitmusChaos will inject the chaos experiments. So kubectl get pods -n, and it's running in the LitmusChaos namespace. So right now we have, let's do it like this probably, we have 1 instance of our application running. Sorry. Here we go. So now let's do a Keptn send event from our hello service, the deployment event that I just showed you. Let's now send this event to Keptn. Keptn will pick up this event and it will trigger the Helm integration to start the deployment. We can already see it's now scaling up to 3 instances. 2 are not ready yet. They are not yet available because there is a readiness pro defined as part of this application, and it will take 30 seconds for it to initiate and then be able to serve the traffic. So after around 30 seconds, we should have 2 ready instances available. And once these are available, here we go, one is already available and the other one should come up quite soon. Once these are available, Keptn will be informed the deployment is finished and it will go ahead and trigger the next phase, which is now actually the chaos experiment. So we can already see the pod delete experiment has now started. There is also a chaos runner managed by LitmusChaos, just started. And one of those other 3 pods will actually be deleted by this chaos experiment. So we can see exactly this one is now terminating and another one is coming up. This experiment, this pod here will still take around 30 seconds to be fully ready. Again, here the readiness probe is running again. So it will take around 30 seconds for it to be ready and also to serve the traffic. But the other 2 instances, they were able to serve the traffic already. So in this run of the experiment, we have not deleted all the instances of the application because we now have 3 instances running of this application and we only deleted 1 of them. The other 2 should be able to respond to all the requests and to serve the traffic. And we will see this in the chaos evaluation, how this is actually impacting the resilience of applications. We just saw that the LitmusChaos managed resources, the chaos runner and the experiment itself, they are now finished. They are also removed again from this namespace, and everything has been now reported back also to Keptn. So let's take a look in the Keptn's bridge. Here we go. The delivery succeeded in this case, and we can see, just move this, we can see the deployment was successfully finished. The tests, both tests have actually finished, and the evaluation has now scored 100% of our quality score. So let us take a look. As we already hoped, the success percentage is now 100%. So instead of killing all the pods, we just killed one pod, or we also did it earlier. We killed one pod, but it was only one pod, only one instance of our application was available. We also did this now to we deleted one instance of our application. The other two were still able to serve some traffic, so that the success percentage of all the probes we sent to our application was 100%. And due to the high availability in terms of at least 2 replicas that were available to respond to the requests, we could also satisfy the probe duration in terms of being faster than 200 milliseconds in response time. So with this, we have found a way to increase the resilience of this one microservice application. There might be other ways, but for our test, we did it with scaling up the application and making it, let's say, high available with 3 instances running of this application instead of 1 instance. So every time there is 1 instance crashing, there is still 2 other instances that can serve the traffic. So we can also see this here. There might be some other numbers. It really depends on your setup, and it really depends on the sizing of the cluster, which numbers you can come up with. But nevertheless, we can see that we did 1 run that actually failed the quality gates. We identified that our application is not resilient and should not be moved to production. We fixed this issue by scaling up the application to 3 instances of the same application and having the traffic shifted between these 3 applications or 3 instances. And we did another successful run of our delivery sequence with a deployment, a test, and evaluation. And in this case, everything is going fine. So thanks for watching this short video. Again, all the tutorials are linked on below this video, and you will find all the tutorials on tutorials.keptn.sh. If you have any questions or if you want to learn more about the project, go to keptn.sh. You will find all the links also on the website. Thanks for watching.